Perfect. So before I start, how many of you guys are developers? Okay, cloud architects? Let's say responsible for any type of application or infrastructure? Okay, quite a few. So, perfect. My name is Luis, last name Guy. That's why he didn't want to pronounce it. He didn't know how. So I'm based out of Miami, and my role is I'm the head of infrastructure solutions within AWS. The idea of today's session is to understand how you can build applications and systems that are reliable and efficient. So for that, and this is going to be annoying. So number one, there are three very important concepts that most people, especially the first two, they tend to kind of combine or mix. Resiliency, reliability, and efficiency. So resiliency, the ability to recover from a crash. Okay, that's simple. If you have a problem, if something crashes, the way you recover, that's your resiliency strategy, okay? It could be seamless, it could be 5 minutes later, it's up to you, but that's resiliency. The next one is reliability. Reliability is everything you can do to prevent a failure. So the more you spend on reliability, the less you have to worry on resiliency. That's simple. And the last one is efficiency. So the concept of efficiency is when you are building something, that thing, it's supposed to do what it needs to do, consuming the least amount of resources, but still meeting your SLOs, okay, your service level objectives. Now, the last two, the way to do that is through performance testing. So what is performance testing? By the way, according to Gen AI, that's me, same shirt, just different shoes. So think about me as the application. Think about the car as the workload, the number of users, the number of transactions, whatever. So that picture was taken in a very specific moment of time. But what happened if I put another card on top of me? What happened if I try to walk? What happened if I get to walk for how long or how fast? So for how long can I hold that car? All those questions are things you have to answer in the context of performance testing, right? So it's the ability of understanding how your system or your application will behave under different load conditions. That is performance testing. Now, most people, when they talk about performance testing, they only say load testing. Where in reality, load testing is just one type of performance testing you should be focusing on. And let's say that you are a company with 1 million customers, right? 1 million customers is the expected load. That's why you should always be prepared no matter what. So that's why emphasis on the word expected. The next one is stress testing. There are two ways to approach stress testing. One is I want to find my performance degradation point or my breaking points, right? Because especially if you're doing end-to-end testing and you have a lot of endpoints in your scenario, different endpoints might have different performance degradation point. For example, your database may be able to support more requests than your HTTP server, and your API, one might be able to do more than the API number 22. So all of that. The other way to approach stress testing is based on my expected load, which let's say 1 million, can I go 2x, 5x, 10x? So stress testing is all about finding those limits. The next one is endurance testing or soak testing. How many of you guys are Java developers or were Java developers? Okay, quite a few. So in development or in general, if you are going to have a memory leak, that memory leak will not happen in the first 2 minutes. It will happen after an extended period of runtime. So that's why it's very important that when you are doing performance testing, you need to understand not only if you want to hit capacity, but for how long can you sustain that particular load. because especially if you're running, a massive event, and that massive event happened to last 3 hours, you gotta be prepared for at least 3 hours. Next one is actually pretty simple. It's just scalability, meaning that if your goal is to be able to support, let's say, 1 million users, you want to make sure that from 0 to 1 million, you can scale. And this is under the assumption that that's going to take a few hours or maybe a few minutes, to go from 0 to 1 million. Now, the next one, I actually like this one a lot for 2 reasons. Number one is most people think about scalability only, but what happens if you're, let's say, running a promotion and that promotion starts at 9 a.m.? What's going to happen is that at 8:55, you will have probably 0 people, maybe 1,000 people on your website. But at 9, it's going to go from 0 to 1 million in less than a minute. So you need to do that, especially if you're doing things like autoscaling, whether it's Kubernetes, ECS, autoscaling group, or whatever autoscaling technology. You want to make sure that your system can autoscale fast enough based on the demand. Now, here is another cool fact about spike testing. A lot of people only measure on the way up, but what about on the way down? Those sudden changes are very important to analyze and understand. When you go from 0 to 1 million in a minute, but also when you go from 1 million down to 500, also in a minute. You want to make sure that your system can downscale appropriately and your application itself can handle that reduction in workload. And the last one, and this is where you take the picture, is volume testing, okay? Volume testing is all about understanding how your system behaves under massive amount of data being ingested or read. You can apply this to your database, files uploads, and so on. And by the way, it's not one or the other, right? You can combine all these tests. Also, based on what you're trying to achieve, you might want to do one or the other. And here is a cool tip. A lot of people, they do this only once before they launch. In reality, you should be doing load testing, at least load testing, on a regular basis. So, once again, why performance testing? Number one, you can scale and deploy with confidence, no more guessing. We have an impressive amount of compute offerings and database offerings. So the easiest way to know which one is the best one for your particular workload is test it, right? And that's how we do performance testing. The other one is reliability and efficiency. As I said, the more you spend doing performance testing and focus on your reliability strategy, the least you have to worry about a resilient scenario. Yes, you cannot prevent a flood, you cannot prevent a fire, an earthquake. There are major events that you will always have to be prepared for because there is no way to prevent it. However, and there are different opinions on what the number is, but it's a significant 2-digit number, the amount of outages and failures that could have been prevented by just doing performance testing. Better experiences, whether you are e-commerce or you are providing an infrastructure or an application for your internal employees, it doesn't matter. You want to make sure that your site or your application or your API responds in 3 seconds or less. Otherwise, you are losing that client, you are losing that customer. And the last one is cost optimization. So if you are developing or launching this particular site, you go, let's say small, medium, large, right? You do a small size, whatever environment, and you get a 5 seconds response time. Okay, let me try medium. Again, you are measuring this by doing performance testing, right? You do medium, oh, now you are getting 2 seconds response time. Perfect. What do you do next? You go large. Okay, now I'm getting 1 second response time. Awesome. What's next? Let's go in extra large. Oh, I'm still getting a second response time. Let me go to XL. I'm still getting a second response time. At that point, what's the sweet spot? The sweet spot is large. Why? Because you are still getting that 1 second response time, maybe that you are going after, but you are not oversizing your system. When you should be doing performance testing. I usually tell this joke that if you are in IT and you are responsible for either code or an application or infrastructure and you are breathing, you should be doing performance testing. Whether it's before a major event, whether it's through unit testing, because you as a developer, before you pass that milestone, you want to make sure you test it, whether it's through infrastructure changes. How many of you guys familiar with Graviton, for example? So quite a few, right? So if you're running on x86 and you want to see, I wonder if I'm going to get any performance gains by switching to Graviton, that's how you do it, through performance testing. And once again, do it early, do it after, and do it always. I said a few minutes ago, if you have an application that, on a daily basis, you want to make sure it's behaving the way it's supposed to, set a baseline, do a load test every morning or every day, identify what's the baseline, what's the sweet spot, right? And then that's your baseline. And then on a daily basis, run it. You want to measure and you want to know when that application behaves, let's say 5%, for example, or could be 10%, up to you. Let's say 5% is slower than usual. You want to investigate what happened, why that particular day that performance is 5% slower. Now, let's say that tomorrow it's 10% faster. Do you think you should investigate? Exactly, right? You should, because most likely something was supposed to do something and it didn't do it, and that's why it ran faster that particular day. So that's why having a baseline, doing daily or often performance testing is extremely important. What to measure? Number one, percentiles. Percentiles is basically what tells you how the consumers of that particular application or that particular API are experiencing that service. And this could be a human, experiencing that particular service, or could be your system calling an external API, or one API calling another API. But that's what those percentiles means. You don't want to go for 100. Again, that's kind of up to you, but 100 give you like everything, like how every single response is being handled. You want to go for 95, 99%, because that's what's telling you is that, let's say 95% of the service requests or requests to that system, that's how they are perceiving the response. You want to look at transactions per minute. You want to look at transactions per second. You want to look at bandwidth. You want to look, very important, at how, especially if you are launching a distributed, launch. Let's say that you have a global site and you are expecting traffic from Japan, Europe, Latin America, North America, and so on. You want to measure that latency not only from one single region, but globally. And this is why most people that do performance testing today, they do it from a single region. That's not a real test, right? Why? Because you're measuring like from your garage into your kitchen. No, you want to see what happened from another neighborhood, from another city, another country, and so on. Errors, no need to explain. If you have an error, you go see what it is and why. And last but not least, resources. Especially if you're going to root cause analysis, you want to see what's happening with your CPU, your memory, and so on. There are three very common, popular performance testing frameworks, and I'm going to go really fast now. JMeter has been around forever. It's really good, really complete. If you are into Java, XML, YAML, go use it. If you are into JavaScript, you can use K6 from Grafana. Again, it allows you to basically develop scripts or testing scripts using JavaScript. And the last one, if you are a Python developer, you can use Locus. Now, and this is where we AWS come into place. If you want to use each one of these, most likely you will have to deploy your own infrastructure for that particular framework. However, we at AWS, we have a solution called Distributed Load Testing on AWS. It's an open source solution, fully supported by AWS, and quick difference compared to AWS services is single tenant. You have to deploy it in your environment, use it. If you no longer want it, you just remove it. We give you a CloudFormation template that within 5 minutes is up and running in production. So let me actually show you how it works. By the way, recently announced as literally just a few days ago, this is version 401 to be precise. When you deploy this solution, this is what you get out of the box. You don't have to build, you don't have to code. Everything is ready to be used. I'm gonna do a quick test. And this is a test that I kind of pre-created just because of time. Let's say that I'm a major, a sport vendor provider, and I'm gonna do a test because something's gonna happen tomorrow, and I wanna make sure that my system can withstand the load. So the name of the test is Sport Global Test. I can run the test now, once tomorrow or a week from now, or I can run it on a weekly or on a daily basis, or if you don't want to use the web UI, you can actually use your CI/CD pipeline and call all these tests through the APIs. So I'm gonna run it now, and I'm gonna use live data. And this is what I was telling you. You can use a single HTTP endpoint, or you can use JMeter, K6, or Locus within this single platform. You don't have to deploy 3 different environments, just once for everything. And I'm gonna keep it simple. I'm gonna do a single HTTP endpoint. You can play with K6 scripts, JMeter scripts, and so on, but here, again, I'm gonna keep it simple. Now, this is where it gets really cool. In real time, if you wanna do a test that's a global test, this environment is set up for 4 regions. You can do it for as many regions as you can, but if you wanna simulate real traffic coming from all over the world, this is how you do it. The solution in real time is gonna go globally to all those regions. It's gonna spin up all the infrastructure you need for that simulation. It's gonna hit your endpoint, and when the test completes, it's gonna go back, clean everything up, and that's it. You don't have to worry about managing any kind of infrastructure. Now, I'm doing 4 regions, and I'm gonna say for each particular region, I can do a combination of how many unique IP addresses, how many concurrent users, and so on. So again, I already have all this data set up. And I'm gonna say, I want this test to go from 0 to whatever total is, let's say 1 million, in 1 minute. And when I hit 1 minute, I want to stay there for another minute. So I'm gonna hit next, and then run. By the way, I'm using the Wi-Fi from the venue, so it's not the fastest one. So what you see now is that region by region is telling me like, okay, this is how many unique IP addresses or containers or tasks I wanna use. This is how many virtual users I want to simulate on each one, and this is kind of what's happening. I'm provisioning all those tasks or containers, and eventually, when they start running, we will start seeing all the traffic going into the system. And I need to finish this in 1 minute, 36 seconds. Now, this is gonna take a few seconds, but I do have another test that's already running. Okay, there you go. Come on, please. There you go. So, there you go. Here is another test that I started right before this session. You see that this is the average response time. This is all the successful requests. Those are the errors. By the way, errors is because this is using auto-scaling, and I made this environment in a particular way that is gonna show me those errors to tell me that the instances are too small, and I'm triggering the auto-scaling event too late. So that's why those errors. And that's kind of how my ramp up is going up, and eventually when I hit my goal, it's just gonna stay flat for, let's say, 1 hour. And if I go back to my other test, still going, it's gonna take a few more seconds, but because I don't have any more time, I'm gonna go back here, and I'm gonna say, guys, If there is something you want to do, either maybe not tonight because you're going to go to dinner or to a party, but maybe on Monday when you get back home, deploy the solution, test it. Within 5 minutes, it's up and running in production. And if you have any question, I'm going to be at the AWS Village from 3 to 6 p.m. doing a much deeper demo into the solution. Thank you very much.